Alright, so go here. Today we're going to talk about water molecule and the physical properties of it. Water's weird. Water's not the same as all of the other hydrogen-based molecules of the same size. So I don't need the laser pointer. I'll turn it off, get my pen. Boom. Alright, let's roll. So basically by the end of this you should be able to describe several different properties of water. Okay? So water is weird. Know that. Basically though, because it's the most ubiquitous molecule, not the most, but it's everywhere, every day, we use it constantly, it's normalized, but it's not normal. It's really weird. For example, water for a covalent molecule that is such a low molecular weight, it's only 18 atomic mass units, it has very high melting points and boiling points, and there's a large gap in between. It's got a very high viscosity and surface tension, again, compared to things that are roughly its atomic mass. It's a really high heat capacity. It absorbs a lot of heat, but we'll talk about that later as we will the viscosity and surface tension. And it's got a weird, its density is weird, like the changes are weird. Okay, so boiling and melting points. First off, the boiling point or melting points are very high. They just are for such a molecular thing. Blah. For a molecule of such a low molecular weight. At 273 Kelvin, so that's 0 degrees, and it's Kelvin, not degrees Kelvin. It's in an equilibrium between the solid and liquid phases. When you see this, I want you to draw this as, it's just I can't get it to do it on PowerPoint. Okay, so it's actually that thing there, so it's a half arrow going that way, half arrow going this way, or a full arrow going that way, but it's separate arrows, which means it goes backwards and forwards. So at 0 degrees, at exactly 0 degrees, it's vacillating between these two. At 100 degrees or 373 Kelvin, it's vacillating between a liquid and a solid, and it won't really change. Now these are at STP, which is standard temperature and pressure, which is 25 degrees, 1 atmosphere. All right, so interestingly, solutes increase the BP, so they move this further that way, and they decrease the melting point, which means they extend it that way. So the liquid phase extends. The density. Okay, first off, you need to have this written down just in case you've forgotten. Density is a measure of the mass per unit of volume, and we measure it in either grams per milliliter or grams per centimeter cubed. Both are correct. So basically, density of water is, well, density of anything is how tightly they're packed together. So particles are squished in tightly. Denser object of the same substance has a higher mass per unit of volume, which means it'll be heavier. So, and that's because the matter's squeezed together. All right, so water achieves maximum density at about 4 degrees Celsius, or what's that, 277 Kelvin. That's its absolute maximum density. And after that, it decreases. But what's really cool is, you see here, that's water. That's water as a solid, and it's got a lower density. Now, think about it. Generally, if you freeze something, the particles contract, they come together, and it gets more dense because they're closer together. This is why solids, as you freeze them, they shrink, heat them, they expand till they melt. Ice is different, because as you melt most solids, and then their volume increases. Their density decreases, volume goes up, density goes down, because the number of particles stay the same. Well, ice is different. Ice doesn't do that. Ice melts, but gets denser, and that's weird. Okay, so I think that's it. And basically it's due to hydrogen bonding, so that's cool. All right, we'll get into that more in a little bit.